Welcome to another edition of RCE. Again, this is Brock Palen. You can find us online at rce-cast.com. You can find an RSS feed, links to your favorite podcast feeder, as well as the entire back catalog. We've been reached out to by a couple people saying we'd love to have the entire catalog in iTunes. It appears we are unable to do that, so only the last couple of episodes are there. So if you want to look at our entire back catalog, visit the website. You can find everything there. I have again with me here Jeff Squyres from Cisco Systems and one of the authors of OpenMPI. Jeff, thanks a lot for your time.
Hey, Brock. Welcome to February. It's a cold month, but we've got some interesting stuff to talk about.
Yeah, we've got another one of those polar vortex things I see them talking about in the news. I don't think anybody in Michigan ever takes them seriously anymore when they talk about those things because it's like, it's Michigan, it's cold, get over it.
Yeah. But you got something coming up in March.
Yeah, so in March, I'm going to be down to the University of Illinois at the ARCC, known as the Advanced Research Computing on Campuses. It's more of a workshop. It's a small gathering of really HPC center, normally on campus, so smaller centers, not like national centers, but the NCSA does help us out with this as one of the hosts. Kind of talk about business models, best practices, condo model, allocation models, what vendors you work with, and things like that. So that is March 22nd through 24th. There's a set of tutorials at the beginning, so if you want to learn about high throughput computing, business models, other things, there's a couple tutorials, as well as the regular conference. So full disclaimer,
so the whole thing
I am one of the organizers.
Is getting ready and getting started with HPC at your organization. Is that kind of the theme?
Yeah, that, and also if you're looking at, making an investment in your institution and you want to look really hard about what's the most effective way to impact the most number of faculty and research projects, just to, really stretch the amount of output for your investment and things like that. So it's a good gathering of people. I will be there. I hope to see others there. If you see me there, be sure to say you like the show. Every bit of encouragement I hear gives me more onus to keep this thing going.
It's helpful, yes.
Yes, it is
All right,
helpful.
well, what are we talking about today?
So today we are going to be talking about EasyBuild. Our guest today is Ken Hoste. Ken, why don't you take a moment to introduce yourself?
Hi, Brock. Hi, Jeff. So I'm Kenneth Hoste. I'm a member of the HPC support team at Ghent University in Belgium. I have a master's and a Ph.D. In computer science as well from Ghent University. And at the HPC team, I'm mostly responsible for user support and training. And as a part of that, I also work on EasyBuild.
So a little side fact here, you said in Belgium, my boss, Dr. Eric McKeelson, who's our Associate Vice President for Advanced Research Computing, is Belgian. And his wife is too.
Okay.
And he's from there. So I don't know if it's the same institution where he went. I know he did his postdoc at Illinois, but I don't know where he did his actual pre-work. So I'm going to have to check on that. Might be a little bit of common information here. So
okay.
I looked him up on LinkedIn, man.
Yeah, for sure. So why don't you give us a little bit of overview? What exactly is EasyBuild?
So EasyBuild is a framework implemented in Python, and it intends to make it very easy for people to compile and install scientific software on HPC systems.
So where does it sit in this realm of, is it something like CMake and AutoComp, or is it like modules? Is it somewhere in between? Kind of where does it sit in this stack?
So it's certainly not a replacement to CMake or any of those tools, and actually it basically wraps around existing build systems. So it's like a layer on top. And in terms of modules, it also leverages modules itself. So it talks to the modules tool and just gets all the information from it as well. So it basically wraps around all these things. It is the layer on top.
So now, what do you mean by that, by being a layer on top? It uses all of the, well, how does this tie together with scientific software, I guess, bring it together?
So let's say you have a scientific software package that you install in a particular way, for example, CMake, make, install. So you follow the steps in the documentation to do this. What EasyBuild will actually do is automate this whole process for you. So if you're installing, let's say, Petsy, it knows that it's supposed to call CMake and then make afterwards and then make install after that. So rather than replacing any of the build systems that the software is using, it just automates the whole procedure.
Now, do you do that with, say, recipes per se? Are there built-in rules into EasyBuild saying, like I say, EasyBuild Petsy, and it says, oh, let me go look up the Petsy recipe. Here's what I do for Petsy.
Yes, exactly. So what it does, so you have the EasyBuild framework itself provides all the supporting functionality to do all this stuff, like run commands and generate files and all these kind of things. And then basically you have a small Python module or almost a Python script on the side, which basically tells EasyBuild what to do, like call cmake, call make install, go there, change that file, things like that.
Now, do you have to kind of make a plugin for every build system? So, like, if you cover CMake and AutoComp, you cover a lot of them, but you get into things like OpenFOAM, and it's got its own build system, and VASP, which basically just has a makefile, edit it at your, threat of death. Can it handle those sorts of things, where you practically are having to patch makefiles or things like that?
No, it does handle all of these things. So the framework itself is basically not specific in any way to any build system. But we do include plugins, or we call them easy blocks, in the EasyBuild release that cover stuff like configure make, cover stuff like CMake. We have one for OpenFOAM and other that I like to call nasty scientific software like WRF or CP2K, for example. So the easy blocks that we include in the EasyBuild release know how to do all of these. And you can implement your own on the site and just give them to EasyBuild, and it picks them up when it needs to.
Okay, so these blocks, are they like helpers, or are they basically the entire community's accumulated knowledge of the options for OpenMPI, the options for CP2K, and those get committed as part of the project, and anybody who downloads it gains from that shared knowledge?
Yeah, that's basically what it is. So it basically defines how you install, let's say, OpenFOAM, and what all the nasty tricks are that you have to do to make it right and make it perform well and so on. So it's basically like an expert system. And everybody that contributes to EasyBuild helps out a little bit, and in the end you do the right thing automatically.
So how does it handle dependencies? So say I want to install, for example, something I'm quite familiar with, OpenMPI, but I also need to have, say, the verbs library or the libfabric library or the whatever library installed before I install OpenMPI. How are those things tracked?
So there's actually another component to EasyBuild. So the easy block is a Python script, let's say, that defines the build procedure. When you want to install a particular version of a particular software package, you give it a small specification file, which we call easyconfig files, which basically tells EasyBuild install OpenMPI version 188 with this GCC compiler. And then EasyBuild takes that information and goes ahead and performs the build procedure for OpenMPI. One of the other things that is specified in there is the list of dependencies together with the versions. So EasyBuild knows which dependencies should be there, and if they are missing, or if the modules for them are missing, it will go ahead and build those first together with the module file, and then go back to OpenMPI and build that on top.
So why is this better than just a bunch of bash scripts? I mean, for most of my applications, I kind of build a bash script, I leave it in the install location, and I can rerun it anytime I need to kind of reinstall that package. Because say, libmverbs went away for some strange reason in the last verbs update, and I need to rebuild everything. Why is this superior to that?
So there's, let's see. The reason we didn't go with bash as a, let's say, implementation language is because it's a scripting language, and it gets ugly really fast if you want to do big, complex things in it. There are other build tools or package managers, if you will, out there that have picked bash and have stuck to it. Like Gentoo Prefix is still using bash. But if you take a look what they're doing object orientation in some way in bash scripts, which it's just very weird. And they claim it's bash and it's easy accessible, but it's really not. You really have to know how things work and so on. And going with a Python as an implementation language and basically defining a framework and a plugin system in Python just makes things a lot more easy to maintain, and you have code. You can reuse code snippets left and right, so you basically implement something once and then reuse it, which you may be able to do that in Bash if you start sourcing around, but it's not really, let's say, friendly enough to implement it cleanly.
So this wasn't a Bash versus Python question, though that's a interesting thing about why you chose Python. It's more of, why don't I just wget a tarball, write a little Bash script for remembering all the options? Why would I want to use a third-party tool like EasyBuild? Like, what's it bring to the table that replaces my usual, I just hard code in all my options and basically type it by hand?
Okay. So basically what it does, the EasyBuild framework contains so many functionality that you can leverage that it becomes a lot more easy than just writing a Bash script. So let's say something simple as executing a shell command. If you really want to do it the right way, you have to not only execute it, but also capture the output, and preferably capture standard out and standard error separately. Check the exit code and all kinds of things. So you can do it with a simple script, but if you want to do it thoroughly and well, and also check on things which are happening, there's a lot more than you have to do. Also, in terms of, let's say, error reporting, if something goes wrong and you want to provide some decent error message that this went wrong and I'm now there, I was executing in that location and so on, this might not be as simple in Bash. So lots of the functionality in the EasyBuild framework is just there, and you can just import it in your EasyBlock and use it. And it makes things a lot more clean and well, easy.
Is there functionality also for saying, hey, I want to install this package 3 different ways? Like, I want to install, package XYZ first with these set of options, and then do a second install with these set of options, and a third install with those set of options. And a common set of options that people might want to do is just different compiler builds, like build it with the Intel compiler, build it with the GCC compiler, build it with the other compiler.
Well, sure. In some way, there is a way to do that, but you would need to define or copy paste, let's say, an easy config file for each of those variants. So you just define a new easy config file that says, I'm now building OpenMPI not with GCC, but with the Intel compilers, for example, or I'm adding a new configure option so it can talk to Slurm or something like that.
So that's handy for building and installing the package, but after the package is installed, does EasyBuild provide functionality for, say I'm now building an end user package and it says I need, an MPI that is compatible with MPI 2.2 or newer, and it figures out that, like, well, I've got OpenMPI, 1.8 over here, or I've got mVapich, whatever over here, and it like picks the right one. Does it kind of remember this across different builds, and is there a way to query that?
Right now, there's not, no. So there's no concept of, say, like an abstract concept of an MPI library that confirms a certain API. No, it's not there right now.
Okay, but what if I just hard code it in? Can I say I need OpenMPI 1.8.x or newer and HDF5 1.8 or newer? Like, can it do that?
No, you're required to hard code all the versions now. And actually, that's kind of a feature of EasyBuild as well. It forces you to hard code all the versions, and you may see that as a disadvantage. But it does help in reproducing the exact same installation later. So if you use the same easy config file again, it will again go back to the same dependencies, the same versions of the dependencies, and you can actually quite easily reproduce an entire software stack like this. This also comes back to the EasyBuild community. So if somebody comes up with an easy config file and contributes it back to EasyBuild, you're reasonably sure that if you try that easy config file, it will work for you as well, and you will get a software stack that works with the versions that are compatible with what you're building.
Okay, and does it automatically like follow all of those? So if I try to build something that requires HDF5 165, which there was an API break between 1.6 and 1.8,
Mhm.
will it automatically kind of like grab the HDF5 165 EasyBuild from the repository and build that and kind of build up all the necessary missing pieces, or will it say I need this first?
No, it will do it automatically. We have well, it doesn't do it by default, but we have a robot option, which basically means if there's something missing, go and find the easy config file for that, do that build first, and then come back to what you're building. So you can install a whole software stack with a single command, basically.
Cool. Now, how portable is this? I mean, I'm assuming you've got fairly robust Linux support. Does that include all kinds of different Linux distros?
Yeah, so initially EasyBuild it was created on our system. So we've been a Red Hat-based shop for quite a while. And there were some specific things in there, but as the community started growing, people started using EasyBuild on SUSE systems, on Debian-based systems as well. And now it pretty much works on, let's say, Linux versions that run on high-performance computing clusters. Some people have been playing around with it on OS X as well. But since that it's not really a target platform for us because we really focus on HPC systems, it kind of works, but yeah, you have to work around issues left and right. So.
Now, this is an interesting thing. You said this in the beginning, too, that you were highlighting scientific software and you're, again, emphasizing HPC systems and things like that. Is there anything in here that is tied to, scientific software or the typical requirements of HPC types of software? Or is it more a generic system that you just happen to be doing in the context of HPC software and whatnot?
Well, there are a couple of things that are specific to installing software on clusters. One thing is definitely that EasyBuild also generates module files for each of the software it installs, so the corresponding module file. So you can just go to your users and say, we installed this software, the module is there, so you can go ahead and load it. And another way, some of the defaults that EasyBuild has are also specific in some way to scientific software. For example, the default compiler optimizations it uses are targeted towards stricter floating point performance or floating point requirements, let's say. For example, the Intel compilers are really loose by default, and we fix that by adding additional compiler flags. Another aspect, I guess, is the very good support for building against MPI libraries. So you can just tell EasyBuild, I want to compile OpenFOAM on top of GCC and OpenMPI, and EasyBuild knows how to call the compiler wrappers, the MPI wrappers, which arguments to pass, and so on.
So you mentioned the Intel compilers in there. We talked a little bit about system packages, but what about binary things like Intel compilers or Portland group compilers and other sorts of things that are very common in the scientific community become as binary? It might just be untar into a directory, but does EasyBuild have a way to handle that and then remember where those are and make module files and all that?
Yeah, exactly. So we at our site and lots of sites that use EasyBuild basically install everything with EasyBuild, including stuff like Intel compilers, MKL, MPI, and so on. Recently, also PGI compilers are supported. And usually, anything that you can tell the installer script or whatever where stuff should be installed, you can make it work with EasyBuild.
Now, when you say...
Yeah,
I'm sorry, go ahead.
So basically anything that you can tell where it should go, EasyBuild can make it work and it will generate a module for it.
So now when you say that sites like you use EasyBuild to install everything, does that include distro packages as well?
No.
I need to... Go ahead.
What I mean is all user-facing software, let's say, all scientific software, all dependencies for scientific software. Some things we deliberately do not install with EasyBuild, one example is libibverbs, for example, because that's really tied to the InfiniBand stack, which comes from the OS anyway. So that's rather difficult to do it on the EasyBuild side. But that's an exception. Usually we just install everything with EasyBuild and have modules for everything.
So back to something I was thinking about earlier, but kind of a different scenario. If I'm a user and I'm trying to install my scientific package, it could be in the format of the module files. It could be a separate EasyBuild command, but I'm looking for OpenMPI with GCC 4 or GCC 5. Mm-hmm. How do I go about finding that? Does EasyBuild help with that, or is it just encoded in the module and I just type module avail OpenMPI and I look at the options? What?
Yeah, so the users that want to build stuff on top of the software that was installed with EasyBuild would typically just go to the modules and do module avail OpenAPI, see what's there. Usually we include the name of the compiler or the compiler toolchain in the module name, so users who know what's going on can easily tell what it was built with, or can easily figure it out at least. And actually we do have some users who also leverage EasyBuild for their own stuff, because they know that all of our installations were performed with EasyBuild. It can be pretty easy for them to just install or define a small easy config file for their software and just leverage all the modules we install. So they don't have to reinstall all the dependencies. If EasyBuild can see the modules that are required, it's happy. It doesn't really care where they live or how they were installed.
So what about, so it's very common to want to know what MPI library with what compiler because of the wrappers and everything. Mm-hmm. But what about options like, does this MPI library include an option like MXM or, PSM or something like VASP? Is it the Gamma version? Is it the, it's got all these preprocessor flags that kind of turn features on and off that are mutually exclusive. Does that get encoded anywhere so I can find it?
You can specify something that we call a version suffix. It's basically a label you can slap on. So if you compile VASP with the Gamma only version, for example, you can name it -Gamma or something like that. Yeah.
Okay, now there's been a couple of different module systems that have come out recently. So there's, the original modules from SourceForge. There's the different twist on it that comes from Texas, the LMOD version, where they kind of organize things differently. Which module systems does it support?
Well, EasyBuild supports basically all of the most common ones. So the classic example or the classic installation is the TCL version. I would guess maybe now 3/4 of all HPC sites are running this, even though it's not really maintained anymore and it's pretty much been, let's say, dead for 2 or 3 years already. So that's what we are still running today, but we're gradually switching to LMOD. So EasyBuild supports LMOD as well. And you can actually tell EasyBuild to generate module files both in Tcl or Lua syntax, and then the Lua ones are specific to LMOD. And it also can talk to there's a pure Tcl implementation as well of environment modules, which is floating around in different variants, but usually these work well with EasyBuild too.
Now, stepping back for just a second here, a couple episodes ago, we actually talked to the main developer for SPAC. And it sounds like there's at least some overlap of functionality here in terms of building HPC software, trying to make it easier for end users and for system administrators. How does EasyBuild compare to SPAC and vice versa?
Yeah, so Todd Gamblin, the main developer of SPAC, is actually, we've been in close contact with him and we've been exchanging lots of information. He's also on our mailing list, for example, and I'm on his mailing list and so on. So there's definitely a lot of overlap between EasyBuild and SPAC, but I also think they are quite different in a number of ways. And I've discussed this with Todd as well. So one thing in my view where SPAC is different is in terms of the target audience. So I see EasyBuild more as a tool for HPC user support teams and making their life easier. Of they get an install request from their users, and they just want to get the installation there in a working state together with the modules and everything. So they can go back to the user and say, now it's installed, load the module, give it a try. While SPAC is, in my view, more for software developers who are developing a large software package that has lots of dependencies, and they want to take care of these dependencies easily, and they want to have the flexibility of changing the versions and the compilers, which are used to build everything. I think that's more of a use case for SPAC, because it gives a little bit more flexibility in terms of dependency versions and so on, while EasyBuild really hard codes or fixes everything.
Okay, so we're not going to see easy SPAC anytime soon, is what you're saying.
Well, at some point I was actually discussing with Todd to work on a merge, but in practice it's going to be difficult. So one interesting thing is that both EasyBuild and SPAC are implemented in Python 2. So they're actually quite close to each other in terms of implementation, and even some parts of the design are quite close to each other as well. SPAC has some concept that's very similar to EasyBlocks, for example. But in the end, we figured that, well, a real merge is never going to work out because of the different target audience, for example, and there's things left and right that we just do different. So it will be difficult. One other thing that we have been discussing and which may end up happening is to work on some kind of common base library, because there are lots of functionality that we both need, and we want to work together on the library to do that once in a good way, and then both SPAC and EasyBuild can leverage that. So there's definitely some interaction there, yeah.
So one of the big complaints about ever installing anything from RPM is that it's always trying to install it in user bin or user local bin, and it keeps overwriting, and I can't have multiple versions installed. At HPC sites, is a pretty common thing. So EasyBuild, non-destructive installs of multiple versions?
Yeah, so every software installation you do with EasyBuild goes into its own prefix. So if you have two installations of GCC, they live next to each other, but each in their own subfolder. And then the module just makes sure that your path and the library path and all that stuff is updated accordingly. So yeah, from the ground up, it's really intended to support multiple versions, multiple builds of the same software package side by side.
So we inject into our module files a lot of extra tags. We basically kind of have these key value pairs. Most of the time they're links, things, but we actually have a script that runs over all of our module files and generates a web page. So our list of available software is always updated with our modules. If you go to the ArcTS website right now, it's broken. A new website's coming out soon. But this is something we definitely do. Is that something that's relatively easy to kind of like inject help text into the module files when they're generated, and maybe inject some of these vendor documentation :URL,
sure,
so documentation URL, that sort of thing?
Yeah, you actually get full control. Well, maybe not full control yet, but we're heading that way over what goes into module files. So some of the help text is by default at least derived from the easyconfig file. So the easyconfig file has the homepage, for example, and a short description of the software, which eventually gets in the module file as well. But EasyBuild, in the EasyBuild configuration, you can specify a module header and a module footer that gets included with every installation. There's ways of defining extra variables in the module file and so on. And it even goes beyond that. You also get full control over the module names and how your module tree will look like. So EasyBuild has a default, which we think is pretty reasonable, but you can reasonably easy redefine how your module tree should look like. For example, all software names should be lowercase, and then the version, and then after that, the label that says if it's a Gamma version only or something. So you get full control over that as well.
Let's say I'm a package author. I'm an upstream package author. How easy is it for me? no pun intended, how easy is it for me to write an easy block to, specify the recipe to install my software? Or is that something more of a downstream action because it's more going to be unique to each site on how they want to install my package?
Well, it really depends on the build procedure your software package is using. If it's something standard as configure, make install, or CMake, something like this, you really don't have to write an easy block anymore. There's an easy block already that knows how to do that, and you can just hook into that. So all you would need to do is define an easy config file, which tells EasyBuild, install this software, this version, use this compiler toolchain or compiler version. This is where you grab the source tarball and so on. And you just tell EasyBuild and use configure, make install.
Now, you said you write that. Are you talking you, the end user system administrator, or me, the upstream developer, package developer?
Well, just anyone who's up for writing the easy config file. We get tons of contributions with easy config files from people that are entirely new to EasyBuild. And it's fairly easy, especially if it's a standard build procedure, to just look at an existing easy config file and change software name, change version, change the download location, and then that's pretty much it.
Okay, now for these variety of contributions that you get, like, again, let's stick with my scenario here. I'm the upstream developer. How can I go look and see what people have submitted for my package and submit my own contributions or updates or things like that?
Okay, so all of our contributions are done via GitHub. So there's a GitHub repository with all the easy config files. So you can look at all the easy config files that have been merged already in the upstream version. Then there might be a couple of pull requests maybe that are still open because they haven't been looked at yet, or they need some testing or some change has been requested for them before they can be merged in. So everything goes via the GitHub repository.
So could you give us examples of a couple of places people would be familiar with who are using EasyBuild today?
Sure. Let's see. So maybe I should turn back a little bit and just talk about our intentions when we first released EasyBuild in public. So this was back in April 2012. The main reason we released EasyBuild, so we were developing it in-house already for about 2.5 years by then, and we felt it was at a point where it may be useful to others, but we weren't quite sure whether we were reinventing the wheel or if there was a better alternative out there. So we basically pushed it out to get some feedback, and reasonably quickly it was picked up by a system administrator in the University of Luxembourg. And then from then, the ball started rolling, and people in Cyprus, in Switzerland, Austria started picking up on it. And let's say after about a year or so, it was pretty much all around the world. So some US sites have picked up on it. It was all across Europe and even down to New Zealand. People were using it. And today, some of the largest HPC sites in Europe are using it already and also actively contributing back. So there's the Jülich Supercomputing Center and also the Swiss National Supercomputing Center, CSCS, has picked it up on their production systems. And there's some sites in the US as well, like Stanford University. There's somebody in Canada who's very active in contributing as well. And we even have companies like Bayer and some others, which I probably cannot mention, are using it as well.
So what about packages? Two things. How many packages does if I download EasyBuild today, how many unique packages does it understand? And then what is the most complicated package you think that's implemented in EasyBuild?
Okay, so right now with the latest release, we have close to 800 different software packages supported. So that includes both, let's say, top-level scientific applications, including all of the dependencies, and then a bunch of compilers, libraries, and supporting tools as well. So all in all, that's about 800. In terms of the most complicated packages, it really depends on what you mean with complicated, but a couple of good examples are WRF, for example, the weather modeling software, which is used on some of the biggest systems in the US. And it's complex because the build procedure that they have is just very weird. It's in no way standard. They have own scripts for configuring and building. Patching is done in a weird way. They don't really provide patch files and all of that. So you really have to go in and do everything manually. And some people spend days on this stuff. And with EasyBuild, it's now as easy as running a single command, and EasyBuild takes care of everything. Other similar packages are like OpenFOAM, the one you already mentioned. And then in chemistry applications like CP2K and NWChem, which are very, let's say, non-trivial to install. In another way, the complexity can also be in the amount of dependencies that you have to take care of before you actually get to the thing that you want to install. And there a good example is Dolphin, for example, which involves over 100 dependencies, including stuff like Petsy and a whole bunch of Python packages that are not available by default, Boost, HDF5, NetCDF, Qt, and so on. So you have to take care of all of these first before you get to Dolphin, the stuff you care about. And it can literally take you weeks. It was quite a bit of work to get this in EasyBuild, but now it's as easy as it's ever going to be to install this from source.
So that's some of the complicated stuff. What's the weirdest thing, perhaps the most unexpected package you've seen come under the EasyBuild umbrella?
The most unexpected, okay. Well, it's kind of a running gag in the EasyBuild community to at some point support Linux from scratch. So basically all the components you need to get a Linux system working. And there's a ticket somewhere in the EasyBuild repositories. I think the only thing missing is libc. And other than that, we can basically install pretty much everything you need. It's not that hard because most of these are just configure, make, install. But yeah, I guess it's kind of a running gag, really.
So what license is this under?
It's GPL v2. So when we initially released it, we wanted to go with a strict open source license because we weren't really sure where this was going. And we felt that going with GPL v2 gave us the best guarantee that we might be getting contributions back rather than people just running off and started playing with it. And in the end, it seemed that worked out well because we've been getting lots of contributions. So it seemed like that was the right choice.
So you mentioned earlier that you're using GitHub. A question I like to ask to other developers is, what version control system do you use and why? Well, we've kind of already answered which one, but why are you using Git and GitHub?
So it kind of grew naturally because we were already using Git and GitHub in our team before we released EasyBuild in the wild. But in the end, I think Git is the only, let's say, reasonable choice if you want to have people contribute back to your project. And GitHub is such a central place nowadays that lots of people are familiar with it and know the interface, know how to send pull requests and so on. So I think that has really helped in getting lots of contributions. One maybe negative aspect of that is for some people it can be a steep learning curve if they are new to Git and GitHub and they want to make a contribution, but they need to figure out all of this stuff first. So actually one of the things we're working on now is to make it as easy as possible for people to contribute back. And the way we're doing that is we're adding support to the EasyBuild command line to just send patches straight from the EasyBuild command line. So you can just go EasyBuild, open a pull request for this thing that I changed. And under the covers, it will run all the Git commands, push to GitHub, and actually use the GitHub API to open the pull request for you. So you don't have to do anything manually at all. And that's been working out really well. And even for me and the other people in our team who are quite familiar with Git, it's very useful to us as well because it takes away a lot of the intermediate steps you have to make to push something upstream.
Okay, Ken. So the one thing everyone wants to know is what's the website to actually find EasyBuild, and probably the Git repo also if it's not on the same page.
Yeah, so the website is hpcugent, one word, .github.io/easybuild, also one word. And from there you can click through to the different GitHub repositories as well. So things are spread out over 3 or 4 repositories to make it maintainable.
Okay, and then if people want to get involved, is there a mailing list?
Yeah, so there's a mailing list which gets, maybe a dozen of mails, a couple of dozen mails every week, so it's quite active. We have an IRC channel as well, so #EasyBuild on the Freenode network, where a couple dozen people hang out every day and discuss problems. We have bi-weekly conf calls as well, where people can just join and listen in. And we actually have an EasyBuild meeting at the end of next month, so end of March in Lugano in Switzerland. So people can join us there too.
Okay, Ken. Well, thank you very much for your time.
Thank you.
Thanks for your time.
Thanks.